Hello, everyone. It's me, Jack, the Generalist. Today I have a special guest, Johanna. Introduce yourself.
Hello, hello. Thanks so much for having me.
Absolutely.
So my name is Johanna Pirker, and I'm a professor for computer science in Graz and also in Munich. So since July, I also took a professorship here in Munich at the Technical University, and yeah. But also like sort of in between, was computer science, game development, and try to bridge a little bit the different worlds in those spaces.
All right. Awesome. So, take us through your childhood a little bit. Before all of this happened, how did that come to work?
This is quite interesting. So the academic path can be sometimes a little bit challenging, especially if you go into computer science. So one of the questions I tend to get asked, like, why am I even in this space? Because this is a space where women are still really underrepresented. And if I would have heard closely to the opinion of other people, I wouldn't be in that space at all. So, like, even though I might have had already some signs that I might be good in computer science, a lot of people told me to not study computer science.
Oh,
Yeah, this was quite interesting. But like, if I go really, really, really back, everything was there. So sometimes you get possibilities because of early access. And one of the earliest experiences and memories I have was me playing Prince of Persia from on the DOS machine of my father, which I was probably 2 or 3 years old. I couldn't write or read yet, but I knew what to enter on the DOS machine, the command line. And I suppose back then, like then being this realm of games, this first game, the Prince saving the princess, Prince of Persia, right? The second game, or like all the other games like Zelda, you're supposed to save the princess. Super Mario, the plumber saves the princess. Everyone needs to save the princess. But it was like always like my world. Like I still had a lot of outside activities, but I was always really close to PC at all. I was never scared to use a PC because I think there's also something when you are on this DOS machine early on, you're never scared to break something because you broke it at some point anyway already. And then, like for games, it was just for me such a beautiful space to go into these worlds, to do things you couldn't do otherwise. And yeah, and at some points, even I remember I was like, I was 12, 13, 14. I started building own homepage projects. This was back then a big deal because there was not a lot of tutorials out there yet. You didn't have YouTube or show yet back then.
yeah.
I might be a little bit older than you are, so this might be like really really old woman memories. But yeah, it was quite interesting to go to to try out things, be a little bit creative. Also Visual Basic, which was a thing back then, but I didn't have a computer science education at school. Not really, a little bit, and it was not a lot of people being interested, whether neither in games nor in computer science at all in my environment. It was really just like a handful of people. So in the end. For me going to then really dare to start studying computer science, everything was actually sort of against that. And I still took the odds and then actually discovered during the studies what computer science actually is, how creative this can be, and that I can be good in this thing.
So, three questions come in mind right now. One question is, how would you say has Austria evolved in the education system to include more computer science in schools from back then till now?
So honestly, since I'm really heavily in this space, trying to be very pushy that we need more computer science education in schools. It has evolved. Absolutely, because like also the tech became way more accessible, because back then not a lot of people did have access to computers at all. Then not everyone had access to the internet at all. So this was something which was really back then something was slowly spreading, and now it would be way more accessible. So there is a lot of a movement to have something like Medienbildung, you would call it in German, education about media usage,
Yeah.
which is important, but it's not the base, because it's quite interesting if you now, because since I grew up using a PC, I at least know what a folder structure would look like, how the general structure of a PC because of that would look like, and this is something, because everything got so accessible, which is good, comes also with the downside that everything is hidden, and just using a tablet doesn't make you good in technology. And this is what we see now with the new generations, that they are sort of good in using technology, but are missing really background knowledge, even heavy users. How does it work? How's the infrastructure? What then? Obviously, it comes with negative sides, because if you don't have the background knowledge, you cannot understand what could be benefits, but also problematic issues when using apps, systems, processes, and so on and so forth.
Okay, but why do you think that issue is like that, where like there's no proper background anymore, or they lack that proper background these days? Okay, but why do you
Because
think that?
everything again is super accessible. The system design has changed again, which is good. It should be accessible, but there is this link missing to the education around this. So again, I would really strongly argue that in schools we would not only have to learn this media education, but actually basic coding skills, how understand how the systems work, because it's quite funny. We do learn in school so much about, so much, but about history, about the past, about us, our bodies, and so forth. But we're like one of the worlds we're living right now, probably a majority of the day, which is the digital world. We don't learn so much. We only learn so little in schools.
Yeah.
And this is, I think, something we need to change.
Yeah, I agree with you. And I do think also, like, because you mentioned back in the day, there wasn't so many resources and you had to dig down, right? I bet you were reading books. What were your resources back in the day?
Back then, magazines. It was quite fun now that you say this. So a lot of like those computer magazines, a lot of, and we had to, I don't know, if you would install a game, you had 20,000 floppy disks which you need to enter. And now, oh wow, you have floppy disk 47 out of 63. Go on, you're doing great. Like I can also remember like some of the games and even codes. You could find code to the games and to small programs printed in the magazine.
Wow.
But then at some points, some of the magazines would come with discs or with CDs. And this was something which was quite nice, where you can try out different demo games or things and explore a little. And yeah, and I think if I try to recall, for instance, Visual Basic, I think many things I figured out by just trying to figure out, just to exploring and often breaking stuff. So there was also a lot of games where I remember trying to, hey, I would love this code not be brown, but to be, I don't know, violet. So you are looking in the file system and try to sort of break the game a little bit. And
wow,
yeah.
That's very interesting, because I can remember myself. Syria, for example, didn't allow any computers until the 2001s or something like that. So that is basically the first nation like introduction to computers, if you can imagine that. So I like the way I grew up. When I tell stories from the the technology interactions that I had, like people in their 40s and in their 50s be like, oh, this is exactly how I grew up too. Like one of the things that I grew up with is like we went to people and we knocked on the door to hang out with. There was no like asking for permission or calling. No, we went there and we knocked on the door, right? That was the way to do it. And one of the main things that I want to bring back to games and computers is like, I did not have any internet access until very later on. And there will be like tools like 3ds Max, for example, where I would literally learn the same way you described. I would just F around, right, and find out. And so that is interesting that you also had to go through this. So you mentioned before that there were a lot of things stopping you from pursuing that as an education, like computer science.
Yeah, it's quite interesting. So even though, in Austria, we do have different sort of schools. So we have something which is called the Gymnasium, which is like focused on a very, I would say, general education. You have more dedicated schools, some dedicated to tech, for instance. And I was on one of those rather broad ones. Interestingly, it focused on languages. This is the thing I'm really terrible with. I'm like the worst person in trying to pick up languages. And it was like I did learn English and Italian and Latin. And then at some point, also later in my life, I'm Spanish. But so it was like, I'm not sure if it was the perfect pick for my head or for my brain. But again, in the end, everything turned out perfectly. But so it was not something, I don't know, I was not particularly good in school also not in math, by the way. So I had to have help and tutors also for my finals during high school. And this is quite interesting because then it came really with a switch. So many people told me not to study computer science because it's not something for you. You're not so good in math, and so on and so forth. And in retrospect, because I had a lot of thoughts why it was happening that way, even though I was doing small little programs, which could have been a sign that this is something for me, that people just did not know what computer science actually is. This is not something back then. I'm not sure if it really changed a lot now. I think it's still a little bit undereducated how broad computer science is actually. Also things like we do have those hype topics, right? We do have at the moment everyone is talking about AI. Right, but actually we're doing AI research since such a long time, and what we're talking about right now in the news is such a tiny part of what is possible or is happening out there, and everyone is jumping on those topics and pretending to understand what is going on, and this is really dangerous. That's why I'm like always trying to be a little bit protective that we do need to understand a little bit better the fields, because also computer science itself, it's such a broad field. And just saying, oh, you're not good in math in your high school, computer science is not something you're going to be good at. This is just really, really weird. So in retrospect, I think one of the major issues was that nobody actually understood what computer science is. That's why I'm also pushing. And still.
That's so interesting. You know, I've also thought about the math part and that I would never be good in computer science. Although, like, if I would get an academic chance, that would be the number one thing that I would pursue, right? Computer science. But can you unpack that a little bit? Like, there's two things to unpack here, right? When you said it's dangerous when it came to AI not to understand what computer science is, I would love to unpack that, but I would also like to unpack the point that we just discussed, which I forgot right now.
I can add one thing about math, which math. In the meantime, because the math thing is something, by now I love math. It's something, again, in school, I probably was not really good in many things in school, but I do feel also in retrospect that maybe the way my brain works could have been supported better with other ways or other tools. But again, that's also a different train of thought. And then all of a sudden, the moment I did study at the university, where the math level is way higher, but you're actually learning in a different way. And are exposed to other problems, and you are exposed to problems which are directly applied to really useful examples.
Yep.
And it was just, I think, 6 months after I started studying computer science, I was a tutor in math for high school students in their finals.
Wow.
This was such an interesting twist. Interesting, mostly girls, because I think I don't know why, but I think it was a different level of trust. But it was this interesting twist from me being in need of having tutors for my finals
Yeah.
versus switching to being the tutor with and having no problems with math at all anymore, just because the problems were and the solutions were maybe discussed in a different way.
Yeah, they were more applied. They were more direct. You've had the dopamine rush of like, why am I doing this, and then actually having it applied to the issue that you're trying to fix. For me, maths is very something that I'm really interested in, especially when I'm doing shaders and visual effects. Like when I got taught what sine is, like the sine wave, simple thing in school, and I would have those like on paper, or like what do you call those two things to solve equations? So like for the test, right? They would tell you this is what's gonna come to the test, and you're gonna have to solve this on paper. I never understood what sine wave was, and it never made sense for me. I just went through it all the way till the end. But when I see it on a like visually on a shader, I could tell I understood it immediately, instantly. I was like, okay, this is what this thing is. And I think it's this direct application. Like even like we talked about games in education, but there's also the part of like, let's take those elements of in maths and try to apply them in an Unreal Engine. It's for free. Like, let us teach the students how to use this on a job. I feel that's very important.
And this is like, for instance, for my tutorials with my with the high school students, I was playing poker with them.
Cool.
And started to explain probability.
Oh.
Or for like here in Munich at LMU, I was teaching computer graphics, and we tried to apply many of the problems. Computer graphics is also heavily math focused. And then try to explain all the things in a very simple Unity application. And I don't know, again, like just seeing those things really helps sometimes. And again, we don't need to make education complicated just for the sake of having it complicated. I honestly still believe that having things which are difficult are important because they are challenging us, making us think, and so forth. But if there are things which help us understand to solve those more difficult problems, we should use everything we get. And the next thing, I think, which is very tremendously different in the education in school versus university, but this is also just, I think, the sense of growing up and that you need still the space from school. But at the university, everything was way more around your own freedom, how to sometimes teach yourself the things. That sounds not weird, but you get the basic introduction in the lectures, and then you get often even more complex problems for the homework, and you have to think. And honestly, especially in engineering, we all very often solve things together and talk this through.
You mean software engineering, right?
And I made for like I'm talking about the math problems now.
Okay, now I meant because you mentioned engineering in
it's software engineering.
Software
sorry,
engineering,
yes.
Yeah.
No, but in general engineering, one thing, the way how we learn to think and how to solve problems is in teams. This is so interesting. Cool. This is very different to other studies where sometimes in humanist studies, sometimes, again, what I've learned is that many of the problems are up to you. And here we have so many group works and project works. Mm-hmm. So we often have problems which are supposed to be solved together in groups of 3 or 4. Yeah. So also for the math problems, sometimes in groups or not, but the best way how you learn is if you explain it to others.
Yeah, that makes so much sense. I mean, I could see the same thing in game development too, right? Where your best work would be when you're working with teams, but to also include that in the educational factor, I feel like that is priceless, honestly. And so you mentioned computer science is very broad, right? Like the term. What would you say to someone who just listens to computer science and thinks math? Like, what would you say how broad it is? Or
Oh,
AI?
it can be everything. So it's like one field is, for instance, HCI, human computer interaction interfaces, where we try to bridge problems between how we as human would interact with the machine. So this is something, especially in the realm of AI now,
Yeah.
how we collaborate, how we can use it for good, and so on and so forth. So those are typical problems there, where we try to really focus on the human side of everything, because this is something which got a little bit lost at some point. In the very beginning,
Capitalism.
everything was really tech focused.
Yeah.
It was not so much capitalism. It was also just, hey, we have this tech. Let's build crazy solutions, which nobody actually necessarily needs, but
The
just for the
buzzword.
sake of
Yeah.
just for the sake of making cool tech
Yeah.
work. This is just us being a bunch of nerds trying out things. But then if you put the human in the loop, this is, for instance, this field of HCI, you have, again, what I always try to underline, that computer science can be and is already used in every single discipline. So no matter what field you're working in, you can have a good and positive impact for so many fields. You can create solutions for medical image recognition. Again, if you think of the realm of AI, one of the most interesting solutions is, for instance, to use it for, and this is also where a lot of the algorithms are based, is image recognition to early recognize tumors and help people. Or again, for automatically recognize dangerous situations, toxic behavior in video games. This is what we are doing, for instance,
Okay, cool.
to identify patterns. So you can use the same things for so many, or similar things, similar strategies for so many interesting things. And so the group I'm leading in Graz, again, like I'm now in Munich in Graz, but if I talk about the Game Lab in Graz, so for instance, we started with like so much research in the realm of games and spaces around that, and we tried to show how this realm of game development, computer science, can be used for different SDGs. So we mapped all the sustainability development goals. Those are 17 goals given by the UN to hopefully make the world a better place, or not so much worse, let's put it that way. And we tried to map all the projects basically onto those goals, to actually show how broad, not even computer science, but even game development can be. So we had games for energy education, for education in general, for consumption overviews, for educating about the microbiome, for general industry applications, to make some processes more safe, to teach about different apprenticeships, because this is also something which is a little bit overseen these days, how cool apprenticeships can be, and games or virtual reality experience can be a very good tool to make people experience things, visualize things.
Yeah, especially like the microbiome part of it, like especially before COVID, I would have seen that becoming like very important. But also like fake news these days, I feel like that could also be applied there too, in sense of like, let's make a game about fake news. I think Polycular is doing that with Escape Fake. I think they're doing a good job in that way. They're also Austrians. I worked with them back in the day. But yeah, it's all helpful to like make a mini version of reality, especially in VR. I guess VR is a huge thing, right? When it comes to studies and research, or was?
This is, I would still say it is, because this is like my main love project or main love direction. So this is something which we're doing so early on. We also, like back then, you used the cave environments, and then we had the early devices from this democratization of the VR developments with the early Oculus development kits. And I honestly, I still believe, even though like I have to fight with a lot of people on that, but VR gives me so many things which no other technology before did to me.
Yeah.
And like I still really fight for those educational experience. This is, I think, also the main reason why I what part of my research became known, which was this virtual reality physics laboratory. Because back then in 2011, 2012, I went to MIT, which is this elite university in the US.
Yep.
This was ranked number one, and I was really grateful to be able to study there at some point. And there's one part to my history, to my childhood, which is quite interesting, because back then when I was probably 10ish or so or earlier, I wanted to become a physicist.
Ah. Cool.
This did not turn out well, but actually, and then I, in my whole high school experience, I don't think we did a single physics experiment. So we sometimes you have. I had this in the talk with Rami and in this podcast, and it's quite interesting. He mentioned this teacher who really pushed him in the most positive way and motivated him. I also had very good experience. I also had not so good experiences, which
same.
also shaped me. And I would say in the end, like some of the experiences which I had, which were not so good, also shaped me in a good way.
Yep.
Because like everything which is happening to me, which is not so good, I try to take and then try to make a solution around that. Like how could it be that someone like after me will not have an experience like this? So many of the tools I researched and developed were sort of tools to support teachers, to give students also like a little bit of autonomy to do physics experiments, for instance, without the need of having access to this fancy physics laboratory.
True. Yeah. I mean, that is super helpful, right? Like, what if the things that you need to play with are super expensive or super dangerous either? Like having that in VR experience.
And this is the MIT project. So basically, when I was at MIT, and then me trying to become a physicist when I was young, but then sort of did not go that way because maybe of missing opportunities, and then seeing those fancy laboratories they would have. Like I think one of those labs would cost $1.4 million or something like this. And I was, this is the way how you can learn. This is the way how a little like tiny portion of people in the world can learn physics. Are you kidding me?
Yeah.
And then we started again, also together with this physicist, really cool one. He was PI of the Voyager mission, so the supervisor at MIT, and he was a gamer also. And he was back then around 70-ish, but played Skyrim.
Oh wow, that's awesome.
And together we started to take those experiments and digitalize all of them.
Wow.
So basically that you have the possibility first in VR, that you can actually go in VR into this physics laboratory. You can make all the things which are usually unseen, seen, the field lines, to better understand what is happening when you have this magnet and the coil, and see all the field lines to understand the physics behind it.
Yeah.
But you can make dangerous experiments, impossible experiments, expensive experiments.
Yeah.
And then when COVID hit, we thought, oh wow, we created something in VR which is super useful for those couple of people who have VR. So we put everything into a web browser. So you can now go into this lab and try out all those experiments for free, basically, in a web browser without any need to have any other tech.
Is there any guidance? Like, did you make different recipes that you could follow, or do you just need to know the knowledge as a physicist? Like, I guess my question is this for everybody or just for physicists?
So this is I think it's very accessible. It has also now computer science experiments and so forth. It's called Maroon. And again, everyone can try it out in the web browser. But the interesting thing here, this was never designed to be a game or anything. This was really designed as an experiment. So you are using it as a tool. Sometimes teachers would come and help you go through some experiments.
Cool.
There are some experiments which you can find online, but actually everything is really for you as like a simulation, basically.
Yeah.
But we have a second project, which is the contrary. We got a big mega grant for that. So the Epic gave us money to start making this physics escape the room educational experiences.
Wow, cool.
And this is now the opposite. It comes with, it does not follow so strictly, because in Maroon everything is actual physics, everything is all the real calculations, which is super heavy in the background.
Yeah.
And many awesome people. Like I think by now, it's an open source project. So
awesome.
I suppose 100 people or so have contributed things to that by now. It's crazy. And the other one is Chimera. And this is a little bit the opposite, where you, again, everything is not so strict in terms of the real science, but it shows you through guiding you through a little bit of an escape of the room experience, where you learn about small math concepts, small how to put together an engine concepts, a little bit how to start the engine with the magnets. And this is just designed to motivate you, to get you excited, to get you thrilled about how cool physics or engineering itself can be.
Yeah. Wow. This is such a cool project. Is it done already? Can people check it out?
Yes, both. Both are on, so one is on Steam and one is just on the website maroon.tugards.at.
We will definitely link those. It's such an interesting field. Like, I really envy you to a degree, because these are such interesting projects. And
I know your projects. I mean, I think both of us are working just in a very cool environment and doing really cool stuff.
It would be so cool to work together one day. I mean, honestly. But anyway, back to AI. How come it's dangerous to not know what computer science really is and just go by the labels, I guess, or by the hype?
Okay. So this is like a Pandora's box. So what I find a little bit sad these days, again, there are many important complex topics, especially in the game dev realm. There are so many important issues to be discussed, especially like about the rights, especially about how it's being used, But for instance, what I find quite concerning, again, we are in the realm of AI since such a long time and using it for so many different application cases. And I got on so many block lists because people are just randomly starting to block people who just have AI in their in their, I don't know, in any description or anything.
Interesting.
Even though, for instance, we're trying to use AI systems to identify toxic behavior. And this is quite interesting that there's so little understanding of what AI is, and what people are scared of is the generative AI, which is a sub category of the whole AI space. And just labeling everything at AI, which also has the name intelligence in it, which is also very concerning to many of us researchers, because artificial intelligence, that is called intelligence, is something which many of us would probably not agree with and would strongly argue with. And this is, I think, making so many people scared, because there are so many things happening at the same time. And again, there are things which we need to talk about and which are
Ethical.
yeah, absolutely. But again, it should not be reduced to that space. And that's where I feel there's a little bit of a knowledge lack or missing understanding of what the whole realm is and what the actual problems are. And I'm not always like this fan of just blocking away potential problems because I feel those are the things and the people who are in the end being left behind. Again, so what, for instance, a lot of researchers are doing these days are trying to research ways, because that's the way we are working will change. I think we all see this. There's already so many people who are using, just like how ChatGPT already changed so many of the processes, but accelerated so many of the processes.
True.
And I think the most important thing is to understand how to use it for, like, in a proper way, how to use it for good, how to, and again, this is what also many of my colleagues are trying to understand, how this is this human machine component to help us to use the machine-based tools in the best possible way. And many studies are already showing that we can be more creative and more, not only productive, because we're talking about production all the time, but especially like even more creative when we work together with AI assistants, for instance. And I think this is, again, something which we can use in the most positive way. But no question that questions like the rights of the data which got used in the first place, and so forth. This is something which obviously are very, very big topics to be discussed. But also there are very like tiny AI models, which are a little bit underrepresented these days, but which are super important. So tiny models which you can train yourself with, which have way lower energy consumption, which is also one of the really, really big topics, and which are only trained on the specific data you want to have it to be trained with. And again, I think sometimes the voices who are then pressing on some of the issues are sometimes a little bit louder than voices who are showing potential good solutions for those problems already. And that's why I feel the conversation and this discussion around this topic is a little bit, I think sometimes a little bit, not reflected on all sides. But again, the next thing is like what we had in the past with every hype. There's so much scam around this as well, and those are also super loud voices. So, and this is the weird thing now. Voices like mine are getting blocked away because of the other voices being very loud and then being put into the same category. And this happened to me with the metaverse, because we are doing research on virtual worlds, right? So the metaverse, the blockchain discussions, of course, was also
which is also computer science.
And then now the AI topic. And again, all so huge topics, and then you're just being put into one box. And AI is the most complex topic, though.
Yeah, because it's affecting everybody's ability to work, I guess. And those are people who were never in touch with technology. You know, we're talking about artists, we're talking about writers. You know, who could write on a paper or who could draw on a paper. We're talking about people maybe that never had computer other than writing emails and stuff like that. So I guess the question here is how do we make that complex thing approachable in explanation as well? Like you explained local AI that you can train on your own. Okay, how approachable is that in comparison to ChatGPT? And the answer is not at all. It's not approachable at all. You need to dig, right? You need to understand what docs are. You need to understand what llama is. You need to understand what Hugging Face is. You have to dig and get all those resources and make them work. And if they don't work, it's frustrating. But ChatGPT, you literally can open the website and you're there.
This was such a smart move from OpenAI. So this is, we talked about this before. that we have all of a sudden something which is so accessible. So everyone is just mainly focusing on that, and it's just being discussed in the chat as well. And because of that, you have a couple of companies having a lot of power, which is also quite an interesting challenge to take. And there's something which I would also add there. So we are putting a lot of thought efforts into the realm also, how to get more of this autonomy back to Europe also, because a lot of things in the AI realm, and also where the data is coming from, where the data is stored, but also like where the main players are sitting, this is either the US or also China is super strong in there. And in Europe, we are losing a lot of autonomy also because of that. So that's why there's a lot of efforts to strengthen research in this field, also in Europe, and to help also companies who want to build their own models, smaller models, accessible models, safer models, and so on and so forth, also in Europe. So this is a huge topic. This is you opened the Pandora's box. Why are you doing this?
Because it's interesting for me.
Yeah.
Nice. I do think there's a misconception. There's miscommunication around the topic a lot, and I'm glad that I get to hear it from someone in computer science, like as a teacher, as a professor, because you people have been involved in this way before any of this hype have ever existed, and to hear your perspective on it I think is valuable. And just because I guess a lot of us don't have the experience to navigate this topic, so having you on talking about that, and also to see through your perspective as a researcher, right? You're literally researching this field since decades, right? AI, and it's just a small part of computer science, which is being occupied by everything else now. It's like, yeah.
And this is something which I sort of find a little bit frustrating sometimes. It's not me, but also other researchers in this realm. Again, that you're trying to make something good out of that, and then like you're saying, I try to explain it, the positive sides, but of course also the challenges we're going to face. But we're all going to face them together, and so it would be important to support finding solutions. And then it feels so weird to be constantly blocked away. And this is a very weird time that while trying to explain things, just because you're doing this already for some long but very different place actually in this realm, that you're still being blocked away sometimes.
I mean, I guess like we need mediators, in the sense of people who are curious from both sides, almost like the technical artist role, basically. Like on my podcast, I have artists on. They're all afraid of AI, right? So to have someone from computer science that could say, all right, we can bridge the gap here. Maybe we could say, maybe don't block everybody that has AI in their title, or maybe just let's all work together to make that, I don't know, new creation, like a car that everybody will drive soon and have a seatbelt,
A friend of mine did create a very cool app for pictures, where she wanted to create a safe space for artists to upload the pictures without having the fear that those are being used for training.
Cool.
I think it's called Kara.
Oh, is it? Oh, wow. She's a friend of yours. Cool.
Yes, yeah. she's fantastic. Yeah. She's coming from the photography realm.
Yeah.
She has also very interesting opinions on the thoughts of
I would love to have her on,
AI
honestly,
also.
because I was a huge fan of the website, and especially the story, like how it caught up like very quickly, and then she had all those bills to pay.
Yes. No, like all of a sudden it was so popular, but of course, like setting up a server, having heavy traffic, and having to store a lot of art is intense.
Yes.
But yeah, she's fantastic. Also, her work as an artist, as a photographer, she did covers for Vogue and so on.
Wow.
So she's very good. And Yeah, and I think there are really interesting ways also as an artist, like if you mention to mediate there, I I I see the fear to be replaced, but if you have your creative style, your creative vision, and so on and so forth, this is something which is so unique, which again AI by itself, AI cannot tell jokes by itself, but you can become a better joke teller by working with AI, and this is like one of those approaches because again, it will not replace us, but it can accelerate a lot of processes. And I think the best solution is to learn how to work with it in the best possible way. Because also tools like Houdini and so on and so forth, they're heavily using procedural generation, which is also a tool, like an algorithmic tool coming from computer science to speed up the process of creating artistic works or environments and so forth. So this was also something which did speed up processes. And there's a lot of tools. I mean, we see it with Photoshop and so on and so forth already, and also Unreal Engine. Tim Sweeney already mentioned that they're working on trying to rethink a little bit this concept of scene graphs, which is the base of how to build a two-dimensional or especially a three-dimensional image representation, and how to rethink a little bit those processes based on AI concepts, AI-based concepts. And this is quite interesting if you follow up the processes to see how it can be useful for you. But of course, be arguable and discussive because, in the topics which are ethical difficult. Again, the rights or what I find, for instance, quite difficult is this is because it's the same with coding. Like if you use now ChatGPT and so forth or Copilot, you will also get to be exposed to my code because I use GitHub, for instance, which is also open source. So I live this open source spirit a little bit. So everyone can access my code. Also the trained models are used with based on this now. And if I talk to programmers these days in companies, computer scientists, it's very clear that the current tools, that the current models are sometimes comparable with the state of juniors, with junior coders.
Yeah.
Will they replace them? To everyone I talk to in this industry, no. You need the human capital. You need what you said earlier in the previous podcast. There's so much different creativity. There's so much different thoughts coming just by being part of the process. The process itself will change. It will become accelerated, will be a little bit different. But again, and it's so important to also as a company see that because it's creative capital and it's capital to be supposed to be trained also, because if we would start replacing all junior positions, there will not be any seniors at all. But this is, again, coming back to the positive side. I know I'm talking now a little bit positive. I just try to show the potential. But what we are trying to work on right now, for instance, are tools, how to use those AI tools and models to help you become better and learn faster, learn specifically for your special needs.
Listen, that is 1,000% correct. Like, here's an example I'm going through right now. Right, so I'm trying to replace Adobe programs with open source programs. So what I do is I have a local AI installed, right? Saving the environment, yay. So what I do is I give it the documentation of Substance Designer, and I also give it the documentation of Material Maker, which is an open source alternative. And I'll be like, okay, give me all the replacement for the nodes, and I would just learn from that, because they might just have a different name. That is all. And so I'm just giving it all those resources. It's giving me the results back. Not always correct, by the way, like 80% correct or something. It's still good. It's still good enough to. It's like having someone who knows 50% about everything. You know, you can't trust it 100%, but you can get there to make your own thought by the end of it. You can make your experience from it. But the danger with that, I think, is a lot of people use it, especially in relationships or. Let's just talk in relationships, right? Like, who's right, who's wrong? Look, ChatGPT told me this. ChatGPT must be right. And it's like, the thing is about ChatGPT is it will hallucinate an answer. It will answer. That's the problem. It will answer. How is it going to answer? Which bias is being used? All of these things behind the scenes that we don't know. And like you said, it's all American. Like, what are the biases here? Special thing we've seen that highlighted a lot with DeepSeek. Oh, it's very very Chinese government oriented, and it's like as if the US one is not, you know.
But it's quite interesting because the bias is also, since it's using all of our historical data, and what are we? All isms are combined in one data source. It's really brilliant. But again, those are things which is important to work with. That's why it's super important to sort of expose oneself. This is like always what I try to say. Try to see how it works, understand it. That's why I'm very pushy again about computer science education early on, because if you understand how this model works, and the basic is not rocket science. If you go deeper, there can get nasty. But like, to understand the base, this is not rocket science, and we could teach this in schools. And if you learn how this is used and what data it is based on, and there's actually like a little bit of a probability system sometimes, then you understand what is a hallucination, that you need to trust, that you cannot trust the outcome, that you need to fact check. So maybe the research, for instance, if you want to research to a specific topic, can be accelerated, but I still need to double check, and I need to know what to double check, how to double check, and what can I trust and what can I not trust. Because it was so very obvious in the first models, because the first models were purely text-based, so it did not have any logical training at all, so you could not do math. And all of a sudden people were, hey, this is so stupid, it cannot like calculate 2 plus 2. Yes, the system which is just trained on text cannot calculate. Right. And this is again, it's not rocket science, but we need to bring this knowledge to the people, because how can you work with a system which you don't need to know like the base things, but at least to understand so much that you understand where the results are coming from. You don't need to know the nasty, all the gritty details, the structure and so on and so forth, but at least the basics.
I think a lot of people are scared about that, and we have 4 minutes left, and that's where I turn to my guests and I ask if there's anything they would still like to talk about or promote.
It was a very, I didn't see the AI discussion coming, and I don't want to sound either too positive or too negative. I do have a very, I think, neutral opinion on that, and I just try to explain always how it's being used, and that there are a lot of issues, like you said, bias, discrimination, the missing transparency, the big companies, the accountability, the ethical concerns about the data, the privacy issues, the potential job losses.
How fast it's going too, the laws can't keep up with it and everything. Yeah.
But again on the environment, energy. But on the other hand, that there are so many positive chances, and I think since everything is going so fast, we sort of need to work together to try to understand also the potentials, but also the potential problems together as fast as possible.
All right. Yeah, that is amazing. And I'm sorry that we didn't get to talk about games, but if you're going to do a part 2, then I have to do part 2 too. All right. So I'll thank you for joining us and for accepting the invite, and let the viewer like kind of know where they can find you if they have any questions.
Yes, thank you so much. So, like, if you want to talk about those topics, I sometimes give also tiny lectures. They're called. They're supposed to be 15 minutes, but the last one was 4 hours. Where I sometimes talk about computer science topics on Twitch and on the YouTube channel, both on Joy Prink.
All right, I'll make sure that I'll link all of this. I'll talk to the viewer just a little bit to say goodbye to them, and then we'll talk for like a minute or two. Thanks everybody for watching. I'll leave all the links down below. If you liked it, like it. If you disliked it, and let me know. Dislike it and let me know why you disliked it. And let's have a discussion in the comments. All right, everyone. Jack Generalist here and Johanna. We both say bye.
Bye.
Bye, everybody.